Dear students, greetings from Dr. T. Sindil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about time and space complexity of algorithms in data structure. What is time complexity? What is space complexity? That we are going to discuss in this video. So this is the week 1, lecture 3, classroom discussion topic 3. We are going to discuss about time and space complexity in data structure. Before starting the lecture, we must know this lecture outcome. After completion of this lecture, students will be able to analyze the algorithm performance using time and space complexity. So what is complexity? Time and space complexity means how much time it will take for execute that particular program, or how much space required for execute that program. That is considered as the time and space complexity. Okay, so we must know that how much time it is taken for complete the task. That is time complexity. Okay, how much time taken to complete the particular task. That is time complexity, and how much memory required to complete the execution. How much memory required to complete the execution of the particular program is considered as the space complexity. Okay, so that efficiency means how fast it will do. Okay, if we are execute one program, that program will take 5 seconds to complete that program. So that means the task is very easy, then it is completed within 5 seconds. So we can say that that is the time complexity of the particular program. In case the program is taken 50 seconds to complete the task, again it's a worst case of the time complexity. It is taking more time to complete. Okay, so those things we will discuss in this video lecture. So normally time means the number of machine instructions which a program executes is called the time complexity. The number is primarily depend on the size of the program input. Okay, so how many inputs we will give, how it will be processed, and how it will be produce the results. Based on this, the time complexity will be there. Okay, so same like that for space. Space, it depends on the two parts. Time is only depend on the number of codes or number of lines in the program. Okay, but space complexity means it depends on the two part of the program. One is fixed part, another one is a variable part. What is a fixed part? Fixed part means how many variables we are declared. Constants or instructions, variables, and structured variables, array and structures. So already we know we are fixed that. So how many space it will occupy? That is fixed part. And variable part means it's a dynamic memory allocation. At the time of execution, it will ask number of variables. Accordingly, the operating system will allocate the memory. Already we know that. Static memory allocation and dynamic memory allocation. Okay. So what is static memory allocation? When we are declared the variable, the memory will be allocated for the variable or constants. That is static memory allocation. Dynamic memory allocation. What is dynamic memory allocation? Dynamic memory allocation means while we are executing the program at the runtime, the operating system will allocate the memory for the variables. That is variable part. Okay. So that is considered the variable part of the program. Based on these two only, the space complexity will be there. Okay. Worst case running time. So the time complexity, we have three categories there. Okay. So time complexity, we have three categories there. Worst case and average case, then best case. Okay. So these three means it is taking very less time. It is taking more time. It is taking average time based on the input. Okay. So example we will perform some sorting operations. Okay. So 5 elements are there. 1, 2, 3, 4, 5 is there. Already it is in the sorting order. When I am performing sorting, it won't take that much time because already it is sorted. This is the best case. Okay. So in case example 1, 3, 2, 4, 5. So when I am doing only one swap, 2 and 3, so it will take extra small time. So it may be like this, or it may be swapped, or any one of the swap may be happened. Then after that it is getting the proper sorting. That is average case. Worst case means it may be shifted all the values. Okay. So all the values should be swapped. Okay, 5 times it will be swapped with all the values. First it will swap, and then 1 comma 5 it will come, then it will check 5 comma 2, then 2 comma 5 will be swapped, then 5 comma 4 comparison will be there. Okay, then 4 5 will be swapped, then it will compare with the 3. So 3 and 5 it will be swapped, then again 3 and 4 it will swapped. So 3 4 5 it will come. So how many swaps are, how many times it will take to complete the entire swapping operations for performing the sorting? Accordingly, we can say these three cases. So worst case means it's the upper bound of running time. Upper bound means it's the maximum time taken to complete the task. Okay, that is the maximum time we have to fix. Example, we assigned one work. Okay, so that work maximum, for example, what is that? 50 minutes I will give to complete one topic in your class. That is the task. Okay, so if I know very well the topic, you also, you peoples also is easily understand the topic. So when I'm explaining first time, first 15 minutes, you understand the entire concept. That is the best cases. Okay. So I'm waiting till complete 50 minutes. I'm explaining again and again for understanding purpose. So still you are listening. So even if the 15 minutes I will explain, 100% you will get idea about it. That is the worst case. I don't want to take more than 50 minutes. Okay, that is worst case. Average case means it may be taking 25 minutes to 30 minutes. Okay, so like you consider it, that is the worst case running time. It will show the upper bound of the running time. That is the worst case. What is the average case? Average case means it's a average time. Okay, so example, one task will complete at 1 hour. Okay, so it may be completed within 20 minutes. So what is average? 1 hour plus 20 minutes divided by 2. That is average case. Okay, so the best case is simply we can say that is the optimal conditions. Optimal condition means already the work is done. It will take only very minimum time. That is best case. Average time means it's not worst case, it's not best case. Average divided by 2 we will consider. Okay. Amortized running time. What is amortized running time? It's to perform the sequence of operations. Sequence of operation means related to loop condition. We don't know how many times that statement will be executed. Okay. So based on that, it will be considered sequence of operations averaged over the all the operation performed. Okay. So what it will guarantee? It will guarantee the average performance of the each opinion operations in the worst case. The next topic is time space trade-off. What is time space trade-off? Time as well as space. Which is better? Okay, if space is big constraint, if space is big constraint, then we have to choose program to take less space at the cost of more CPU time. Okay, we here time it will be considered CPU time. So we have to occupy if space is the big constraints. If example in your system have very less memory. Okay, so you have to complete the task within that memory. Then you have to spend for CPU time. Okay, it may be faster. If it is more faster, then the memory will be adjustable. And then contrary, what will be happen? If time is major constraint, time is the major constraint, space is more, but we don't have time. So what we have to do? One might choose the program that takes minimum time to execute at the cost of more space. Space is more. Okay. So what is that now? 2 GB RAM is there, but you have very less time. Then that time is the constraints. So with more space, how much time it will take? It will take only minimum time. That is the time space trade-off. Okay. So now time and space complexity. How to express it? Okay. So expressing complexity is how we are represent it. So we want to predict the rate of growth of the complexity as input size of the problem increases. So the maximum time and space complexity based on the input. Okay. So how many inputs you are given, how much time it will take to complete the execution. Based on that, number of input is less or more or average. Based on that, it will be. There are multiple algorithms that find a solution to a given problem, and we need to find the algorithm that is most efficient. So whenever we are writing the algorithm, what we expect the algorithm will execute within the short time, within the short memory, then you have to complete the task. Okay. So that is the important things. So there is big O notations is there normally. So if we are mentioning this time complexity f of n, okay. So here n is the function and number of inputs. Based on that, it will be represented using big O notations. Okay. So it may be n or n square or log n, 2n, like that. It is based on the number of inputs. Okay. So there is many things are there. Big O notations, theta notations, and omega notations. So many notations is there that you will study in the design of analysis and algorithm subject. Okay. So here you know that complexity means how much time it will take or how much space it will take. That is, you have to remember it. Okay. So now algorithm efficiency. If a function is linear, okay, so already we said that we have to consider the functions f of n. So based on this only, we have to evaluate the complexity. So f of n is linear. There is no loops, there is no recursions. So what is that? Directly, whatever the number of instruction is there, that is the time or how much number of instruction is there, that much seconds or that much nanoseconds will be taken further. Okay. So directly we can say there is whatever n value is there, that is the time complexity. N is the complexity. If 10 input is there, means it's 10 is the input. That is the time complexity. N time it will take. Okay. If an algorithm contains loops, then whenever the algorithm contains loops, the efficiency of that algorithm may be vary depending on the number of loops in the algorithm. Okay, it's how much time it wants to execute or complete the entire loop constraints. That is based on the loop. It will be decided. So now you just consider here linear loops. What is linear loops? Okay. So linear loops means the number of inputs are similar, same number of times the statements in the loop will be executed. Okay. So for example, single loop is there. That loop will execute that number of times. The same iteration and the number of loop factor also same. That is a linear loop. Okay. Because the number of iteration is directly proportional to the loop factor. What is the loop factor? It is this is the loop factor. Okay. How many iteration? This is the iteration from the initial point to up to last point. So this is the loop factor, and 100 is the loop factor. Okay. So based on this 100, up to reach the 100, how much time this loop will be executed? Okay. That is linear loop algorithm. So if 100 is there, I plus plus means only I value will be incremented one by one. So how much time? 100 times. So directly proportional, I already said no, that function of n equal to directly proportional to n if in case of linear loop. So if f of 100 means performing this 100 instruction, we need 100. So this is, we can write like this, f of n equal to n. So that is linear loop complexity. So now we will discuss about if in case same linear loop we will consider, but what is the factor here? The loop factor is half. Okay, so loop factor is half. Every second, every 2 times it will be execute this loop. Okay, so for example, I plus 2 means 0, 2, 4, 6, 8, like that it will perform nearly n by 2. Okay, so like 50 times only this loop will be executed. That is n by 2. So that's why we can write f of n by 2. Now we can consider the logarithmic loops. What is logarithmic loops? Wherever we are using plus and minus, the loop constraints I, I plus plus, I minus minus, I plus 2, I minus 2. Like that we are writing now plus and minus. These are the linear loops. While we are using this multiplication and division in the loop factor, then automatically it is, that is the controlling variable, that is divisible or multiple by 2 means it will perform the logarithmic operations. So logarithmic operation means it will be, if you just see 1000 is the values, but this loop will execute it only 10 times. Example same here. Here also it will start from 1000 to 1. It will be divided by 2, means it will execute again only 10 times. Okay, so this is logarithmic of time. So how we can write it? F of n equal to log of n. Okay, so this is the time complexity. When we are thinking about this multiplication and division, totally it is not executing 1000 times. It is log of 1000. It's approximately 10. So how it will be identified? Log of 1000. So approximately it is 10 point something it will come. So the 10. The loop will be executed only 10 times, not 1000 times. That only I am telling. Okay. In second loop also same thing, divided by 2, no. So it is also taking only 10 times. So when we are using multiply and divide, it will be used for log n. Okay. So I already said logarithmic loop. Okay. So when we are saying logarithmic loop, it will be used for multiplication division operations while the control variables in the loop. The next one, nested loops. What is nested loop? Nested loop means loop contain another loops. Okay. So one loop, example, this for loop is there. This for loop have another for loop. So that is considered as a nested loop. Already we discussed. You also know very well. So if nested loop means again how much iteration is there. Based on that, the time complexity is there. Okay. So in the when we are thinking about nested loops, we have again three categories. One is linear logarithmic, another one is quadratic, then finally dependent quadratic nested loops. These three categories there. Linear algorithmic means directly we will use this logarithmic is there, no multiplication symbol is there. It will run only logarithmic of 10 times. 1, then multiply with the 2, 2 into 2, 4, 4 into 2, 8, only 2, 3, 4 times only it will execute this entire loop. But this loop execute 10 times. Okay. So this is for logarithmic of 10. It may be around 3 values. 3 times it will be executed. Okay. 1 and 2 and 4, then 8. Like that it will execute. So this is for log 10. This is will execute 10 times. So totally we can say 10 log 10. So how we can say that n log n. So this is the time complexity of the nested loop with logarithmic. Next one is quadratic. What is quadratic? Quadratic means number of iteration in the inner and outer loops are same. Inner loop and outer loops are equal. Then we can say that that is a quadratic loop. Okay, how much time it will execute? 10 into 10. Okay, so totally 100 times it will execute. 100 means 10 power square. Okay, so 10 square. 10 means n values. How many input you are given? That many values it will take. It is n square is the time complexity for quadratic loop. Finally, dependent quadratic loop. Okay, so here what is the, we have to consider number of iteration in the inner loop is dependent on the outer loop. Okay, so here you see what it is there. Inside inner loop is based on the outside loop. Okay, so I value 10. So that much time it will execute. So how it will be executed? The inner loop will execute just once in the first iteration, twice in the second iteration, thrice in the third iteration, 4 times in the fourth iteration. Like that, it will be executed. Okay, so it is based on the inner loop execute based on the outer loop. So that is considered the dependent quadratic loop. So this loop will be used for n into n plus 1 by 2. Why? Because that number of values divided by 10, average value will take 5.5. Okay. So normally n into n plus 1 divided by 2 we are calculate now. So that is the time complexity for this method. So now you see we are in the position to discuss the reflections part. I given one snippet with for loop conditions. What is the time complexity? You have to identify. I will give 10 seconds time. If you are correctly identified, we will proceed further. Otherwise, you will go back and watch the video how to identify the time complexity for the given snippet. Then you have to continue. Okay. So your 10 seconds starts now. Okay, now your time is going to over. I hope you have written the correct answer. You will compare with my answer. If you have written this answer, this is correct. Okay, n by 3. So loop will be executed 3 times. Okay, every 3 it will be executed. So n by 3 is the answer. If you have written the correct answer, we will proceed the further. I will go back and watch the video. Then you will try to answer properly. This is a summary topic. What are the things we have discussed? What is time and space complexity? So time means how much time it is taken to complete the entire execution. Space means how much space required to complete the execution. Worst case running time means it's the upper bound of the time it is taken for complete the entire task. Average means average time it will be considered. Best case means it is optimal solution. It's the minimum time it is taken to complete the entire task. Amortized running times already we discussed, and time space trade-off based on the time. If time is the constraint means with the minimum time we have to complete the task with more space. If space is constraint means we have to use more time to complete the space. Okay. Okay. So expressing time and space complexity, we already discussed using f of n, using this that we are discussing. There is big O notations are there, big O notations, omega notations, theta notations, like the many notations are there to represent the complexity that we will discuss in the DAA subject. Algorithmic efficiency, how it is working, and under that category, these loops, how it is working, linear loops, logarithmic loops, nested loops. Under the nested loops, how these three categories are working, and what is the complexity that we are discussed in the video lecture. Now we are at the end of this video lecture. You just practice this answer for this question. Write the algorithm for finding factorial number in between 50 to 1000. Okay, so already you know how to find the factorial number, but I given the range 50 to 1000. So you have to find out the numbers and calculate the time complexity of the algorithm. So you have to perform and how much time it is taken to complete this. You identify. Change the algorithm as using recursive function and calculate the time complexity. So normally you have to find one method. After that, you have to change into recursive method and how much time it is taken. You compare both the results and you can finalize that which is better. So lecture outcome revisited. Having completed the discussion on time and space complexity, now students should be able to analyze the algorithm performance using time and space complexity. If you have further doubt, you just read the chapter 2, 2.8 time and space complexity in Rima Tareja textbook and reference book. Further doubt, you can visit the tutorial sheets. Even if you have doubt, you noting down the doubt, we will discuss in the classroom discussion. I hope you are enjoyed this video. Thank you very much for listening with passion. Okay. Thank you one and all again.